graphing ellipses. Today when we get done, you should be able to write an equation for an ellipse. You should also be able to graph an ellipse given the equation. Those two things are what we should be able to do once it's all said and done. All right, so the first thing we need to know is what is the equation for an ellipse? Well, as I just mentioned, it's going to be very similar to the equation that we had yesterday for the circle, and that was x minus h squared plus y minus k squared. So we're going to start off pretty much the same as we did yesterday. Now, yesterday the equation was equal to r squared. The problem is the ellipse does not have a radius. So instead of equaling to r squared, the equation is going to be equal to a 1. Anytime we're working with the ellipse, the equation equals to 1. Now, along with this, we're going to have a little something extra down here at the bottom of our x minus h and our y minus k. Below the x minus h, we're going to have an a squared. And below the y minus k, we're going to have a b squared. And we'll talk about what that represents here in a second. But that's the equation we're going to be working with today. You'll notice very, very similar to the equation of a circle. Now, just like yesterday, the circle has a center. Well, so does the ellipse. It also has a center. And that center can be found by HK. Just like we did yesterday, the center of a circle is HK. HK is also the center of our ellipse. But here's where it's going to get a little different. Ellipses do not have a radius. They don't have a constant distance around the center. It's different. So we have a horizontal distance from the center of the vertice, and we also have a vertical distance from the center to the vertice. Our horizontal distance is going to be A. And when I say horizontal distance, I'm talking about the distance from the center to the right or the left of our ellipse. And the vertical distance is going to be B. And when I say vertical distance, I'm talking about the distance from the center to either the top or the bottom of our ellipse. So, in order to write an equation, we're going to need to know what's the center, we're going to need to know what's the horizontal distance, and what's the vertical distance. If we know those three things, you should be able to write me an equation for the ellipse. All right, so let's see how this works. We've got 3 examples that we're going to look at here. Number 1, they give us the graph, and we got to come up with the equation. Well, to get that equation, we need to know 3 things. The first thing we need to know is what is the center of this ellipse? What is the center? 1, 2. There's your center. But along with that, we also need to know what's the horizontal distance. In other words, what's the distance from the center to the right of that ellipse there? What is that distance? Huh? 5. We also need to know the vertical distance, the distance from the center to the top of this ellipse here. And what is that distance? 3. So we're going to need those 3 things in order to write the equation. So here we go. We're going to write the equation. We're going to start off with the center. Just like yesterday with our circles, the signs are going to be opposite. So we're going to have x minus 1 squared. Signs are different. Then we're going to have y minus 2 squared. Again, notice how my sign is different. And all of this equation is going to equal to a 1. All ellipses are equal to 1. Now, don't forget, right below this x minus 1 and y minus 2, we've got to add something else. So let me flip back to the equation that I gave you. The equation that I gave you said that we were going to have a squared and b squared. In other words, whatever a and b are, we're going to have to square those 2 numbers. All right, so underneath the x minus 1, we need to square the a. So what are you going to get if you square the a? 25. Underneath the y minus 2, we need to square the b. What do you get if you square the b? 9. There it is. That's the equation for that ellipse. Let's try the next one, number 2. Again, for number 2, we need to start by finding the center. What is the center of that ellipse? Negative 4, 1 is the center. Now what we need to do is find the horizontal distance, the distance from the center to either the right or the left of the ellipse. And what is that distance? 1. Now I need to find the vertical distance, the distance from the center to either the top or the bottom of the ellipse. And what is that distance? 4. So I've got everything I need in order to write my equation. So let's write the equation. We're going to start with the center. X plus 4 squared. Remember, the signs have got to be different. Y minus 1 squared. Again, the sign is different. The equation is always going to equal to a 1. So we need to put something underneath this x plus 4 and y minus 1. Let's start with the x plus 4. What goes underneath it?
1.
1. That's what you get when you square 1. What goes underneath y minus 1? 16. And that 16 is from 4 squared. 4 squared would give us a 16. So there's the equation for number 2. All right, let's do one more here, number 3. Let's start by finding the center. The center this time is 0, 0. Our horizontal distance, the distance from the center to either the right or the left of the ellipse would be 5 or 6. 6. Then we're looking at the vertical distance. That's the distance from the center to either the top or bottom, and this is 2. Now, yesterday when we did our circle, because our center is 0, 0, rather than putting plus 0 or minus 0, what we did instead is we just wrote it as x squared and y squared. And we can do that because the center is at 0, 0. Of course, it's still going to equal to 1, like the other 2 examples. But we do need to put something underneath the x squared and the y squared. We need to square our a and our b. So, what goes underneath the x squared then? 36. That's 6 squared. And underneath the y squared, we need a 4. That came from squaring the 2. 2 squared is 4. So there's the equation for number 3. So as you can see, guys, it's not much more difficult than what we did yesterday. It's pretty simple. All right, let's take a look at the next one here, number 4. This time what they've done is they've given me the equation, and I got to come up with the graph given that equation. So in order to do that, the first thing I got to know is where is the center of this ellipse? So can y'all tell me by looking at the equation what the center would be? 3, negative 2. Remember, all we're doing is looking right here and changing the signs. So we're going to go to our graph, and we're going to plot that point 3, negative 2. This is going to be our center of the ellipse. Now what I need to do is find the value of A. We need to find the horizontal distance. Can you tell me what that horizontal distance would be? 4. All it is the square root of 16. So what I need to do now is move 4 to the right and 4 to the left from my center. So that's what I'm going to do. 1, 2, 3, 4 to the right. 1, 2, 3, 4 to the left. These points that I've just plotted are called vertices. What are those 2 vertices? What are the ordered pairs? What are those 2 ordered pairs we just plotted?
Negative 1, 2. Negative 1, negative 2.
Negative 1, negative 2. And the other one is
8, negative
8, negative 2. All right, 4, 5, 6, 7. Yeah, 8, negative 2. All right, so those 2 points are called vertices. Now we need to find the vertical distance. That's our B. What's our B going to be? 6. The square root of 36 is 6. So this time what I'm going to do is from the center, I'm going to go up 6. 1, 2, 3, 4, 5, 6. And I'm going to go down 6. 1, 2, 3, 4, 5, 6. These 2 points are also called vertices. What are those 2 points? What are their ordered pairs? 3, 4, and 3, negative 8. These are the vertices. Once you have those 4 points, all it is a matter of connecting and making your ellipse. So this would be the ellipse for the given equation. All right, let's turn to the next page. Just like yesterday, on this page, what they've done is they've given me several ellipses, and from those ellipses, I've got to come up with their equations. Now, they've already done D for us as an example. What we're going to do is we're going to do E together, and that's this ellipse right here. So, in order to come up with this equation, the first thing I need to do is find the center. What is the center of this ellipse here? Negative 4, positive 5. That's our center. But I'm also going to need the horizontal distance, this distance right here. What is that distance? 3. I'm also going to need the vertical distance, and that vertical distance is 2. Now that I have these three things, I should be able to come up with my equation. And that equation is going to be x plus 4 squared. Notice I changed my signs. Y minus 5 squared. Again, I've changed my signs. Equals to 1. And now underneath the x plus 4 and y minus 5, all we're going to do is square our a and our b. So let's start by squaring the a. What do you get when you square the a? 9, so that goes there. And if I square my b, I get a 4. So that's the equation for the ellipse E. What you're going to do for me in a minute is you're going to do the other 3. You'll do the other 3. Let's take a look at number 6, though. Number 6, a little trickier here. Notice on number 6, what they've done this time is they've given me 3 points, 3 ordered pairs. They did not give me a center. They did not give me the horizontal distance. They did not give me the vertical distance. All they've done is given me these 3 points. And from those 3 points, somehow I've got to come up with an equation. Well, from those 3 points, look closely there. Is it possible for us to come up with a center simply by looking at those 3 points? Yes. Can you tell me what that center would be? This point right here. What would that be? What is that order here? 3 for the x, and we know that because it lines up with these other 2 points, 3, 11, and 3, negative 1. Can you tell what the y value is? 5. And where did you get 5 from? From this other point. We can tell that it lines up with that point, and the y value on that is 5. So simply looking at those 3 points, we were able to figure out that the center is at 3, 5. So now that I know the center is at 3, 5, would it be possible for me to find this horizontal distance? Remember, horizontal, we're looking at the x's. Right now the x is at 3, and we're going all the way to 11. So what is the distance from 3 to 11? 3 to 11 is 8. And that's the distance, horizontal. What about the vertical distance? Right up here. Now we're looking at the y values. We know we're starting at the center here, which is 5, and we're going all the way up to 11. So that distance would be what? 6. So at this point, I was able to figure out what my center is, what my horizontal distance was, and what my vertical distance was. At this point, we can write my equation. And that equation is x minus 3 squared, y minus 5 squared. Remember, it's equal to 1. And underneath that x minus 3 and y minus 5, I need 2 numbers. What's the first number I'm going to put here? X minus 3. What goes under that? 64. All that is a squared. And then over here, b squared is 36. So there's our equation to number 6. What I'm going to do is I'm going to let you try this other one on your own. Try it out. Now, on the next page, this was like your assignment yesterday. On this page, on there, they give you 4 equations. And from these 4 equations, you're going to give me their graphs. So when you get done, you should have 4 graphs here. Now, just a little tip here on number or letter C. Notice how y minus 6 squared has nothing underneath it. How can you write that as a fraction so we do have something underneath it? What can I put underneath? A 1. So go ahead and do that for me. This way you know how much vertical distance you got. All right, so that's that one. And then, of course, on number 8, you've given the equation. And from this equation, you're going to answer the 2 questions for me. Now, page 4, the last page, don't worry about that. We'll get to that tomorrow. So do not touch the last page. So you're going to finish everything up to number 8. If you have time, you can go back and finish up yesterday's assignment as well. All right, let's get started here.